is studied by the means of, right? Physics is studied by means of physical quantities. Yes. And what are those physical quantities? And yeah, okay, awesome. Yeah, okay. So these are the quantities which can be measured, isn't it? Yeah. So these are the quantities which can be measured. It's not like that your emotions, right? Emotions cannot be measured, right? Or else what? It cannot be measured. Whatever things, happiness, sadness, right? So these are not physical quantities. Physical quantities are the one which can be measured. Okay. So we studied these quantical quantities only, right? And we cannot measure emotional quantities, isn't it? Yeah. So just a second. Yeah. Okay. So we cannot measure emotional quantities, right? So there are now, it's not like that there are only some physical quantities. Using these physical quantities, we can make another quantities also, isn't it? And make very different kinds of quantity. Okay. So these are a set of physical quantities, right? By which we can express all other physical quantities, right? But no fundamental quantity can be derived by other fundamental quantity. Okay, right? So no other fundamental quantity can be derived by other fundamental quantity. Okay, so these what you told, these are what fundamental quantities, isn't it? Right? And any other quantity cannot be derived by them. Okay, so they are the one which will remain the same. Okay, yes. So these are what? Okay, now what are those? What are those? There are 7 fundamental quantities, isn't it? What are those? Hmm. Yeah. Yes. Length, time, mass. Okay. Yes, very good. Right. Current, temperature, and yeah, right. Intensity of light. Okay. Right. So yeah. Right. So there are 7 fundamental quantity, but what happens that 2 supplementary quantities are also given, isn't? By yes. Okay. So this is what it happens, right? Now what happened that there are many types of units around the world, isn't it? And each country have different kinds of unit. Okay. So everybody was confused which unit where to use, right? Like suppose in some country they used to measure by the foot of the king, isn't it? In some country they used to measure by some length, isn't it? So everybody was confused. So all the scientists of the world sat around, right? And they created some organization. Okay. This is that organization system, the international. Okay. And whatever they tells, these are the standard units which are have to be followed. Okay. Right. So they have created some quantities which you call it as fundamental quantities. Okay. They have even given some symbols of them, right? And they have given unit also. Okay. So in the NCERT, this is given very much more elaborately. What are these fundamental quantities? Okay. So the first one is what you have. First, the very first basic quantity is mass. Yeah. Okay. Which symbol is M, right? And its SI unit is kilogram. Okay. This is its SI unit. Okay. Now this mass is actually a piece of block which is kept in vacuum somewhere, right? Okay. Now the second is length. Yeah. Which is measure symbol is L and its SI unit is meter. Yeah. Third is time. Okay. Symbol is L and its SI unit is meter. Yeah. Third is time. Okay. T. SI unit, what is time? Second. Okay. Fourth is temperature. Fourth is temperature. Kelvin, or you measure it with theta, its SI unit is Kelvin, right? Okay. And another one. Yeah. Electric current. Very good. Yeah. Electric current. The symbol is I and its SI unit is ampere, isn't it? Then you have amount. Amount. Okay. Which is mole. This one you missed. Okay. This is also mole. And this is luminous intensity. Okay. Which is Scadella you express, right? And this is. So these first 6 are very important. Okay. So these are what fundamental quantities. Okay. Now there are some supplementary quantities also. Okay. Supplementary quantities also. Right. Supplementary quantities. So which are what? Plane angle. Right. Plane angle, which is theta. Okay. Its unit is radian. Isn't it? Then second is solid angle. Yeah. Its unit is steradian. Right. So this will hardly come. This will come use in 11th class. This will come use in 12th class. Okay. Theta is how much? Length upon arc, isn't it? Yeah. Arc length upon radius. This is what? Theta. How do you measure theta? Can you tell me? Yeah. Okay. That also. Radian and degree. Can you tell me the relationship between radian and degree? Yes, very good. Okay. Now then you have, yeah, so let us write that also. 1 radian is how much? 57.5 degree. Okay, or can I write pi by 180 degree? Yes, sir. Yeah, that I can write. Okay. Because pi radian is 180 degree. Yeah, so 1 radian would be how much? 180 by pi, right? 180 by. Yeah. Yes, sir. I have pi radian as 180 degree. So 1 radian will be 180 by pi. Okay. Now then I have derived physical quantities. Yeah. Okay. Derived physical quantities. Okay. So what are they? What are they? Area, volume. Oh, yeah. Units obtained. Units obtained. Very good, right? Units obtained from fundamental quantities, isn't it? Yeah. Units obtained from fundamental quantities. Right. Now there is one expression, right? The expression, right, of derived quantities. The expression of derived quantities in terms of what? Fundamental quantities. What do you call it? Dimensional formula. Very good, right? You call it as dimensional formula. It's called dimensional formula. Okay, so that's what we have to study. That's the most important thing. Okay. And the power of fundamental quantities, right? What do you call it as? Dimension. Yes, it's called as dimension. Okay. Yeah. So that's it. Right? Call it as dimensional formula, and the power is called as dimensions. Okay. Right. Now there are some important points we will discuss. Okay. Right. There are some important points. Okay. So what are they? First point is that length, okay, radius, okay, and height. What else? Distance, displacement, okay, are all length, isn't it? Okay, then what else? The change in a physical quantity is same as that physical quantity, isn't it? Yeah. Okay. The average of a quantity is that same quantity. Okay. And what do you think about multiplication? Multiplication of some number, right? Or scalar does not change that quantity, isn't it? Did you understand this point? But if some other quantity I multiply, then it changes, right? It can change, right? So these are the important points which you have to remember here. Okay. Okay. So these are some important points which we have to remember, right? Right. So this is done, whatever we had theory. Okay. And obviously you know this all. Yeah. Okay. So, right now, what we will do, we will try some questions of dimensional formula. Okay. So since you know, it will be a good revision for you. Okay. Right. And right now only you recite all these formulas, right? Okay. Now only you recite all these formula which I'm telling you. Okay. So what, first of all, tell me what is the formula for pressure? Force. Force upon area, right? So as I'm telling you this formula, you should recite them for the right. So force, what are the dimension? Right. So, you have pen and copy, right? Yeah. Do it in your pen and copy. At the end, tell me. Okay. And we will also derive that. Okay. Tell me the final answer. What it is? Very good. Okay. M1 L minus 1 T power minus 2. Okay. Yes. Okay. Momentum also you have derived. How much it is momentum? M1 L T minus 1. Okay. Momentum is how much? Mass into velocity. Okay, work is how much? Force. Yeah, right. The force times displacement. Power is how much? Work done upon time. Okay, kinetic energy is how much? Half mv square. Okay, potential energy is how much? mgh. Okay, so in IIT JEE, what you can do that you can guess the answer by dimensions also, right? But they will not do this because they are much more clever than you, right? But you can guess the answer by dimensions also. Okay, anywhere, right? Okay, so force, how much it is? Mass into acceleration divided by area, isn't it? Area I can write it as L square, right? So m. Okay, then acceleration is what? L t to the power minus 2, isn't it? Divided by L square, right? So how much I get? M L minus 1 t to the power minus 2, isn't it? Yes. Yes. This one is much more simple. Yeah. So m I have velocity is Lt minus 1, isn't it? So simple, Lt minus 1, which is there for the force time displacement, right? For force, yeah, force directly you have to remember mLt minus 2 its form, okay? Because you'll be getting it even is and again, okay? So force is mLt minus 2, directly you have to remember mLt minus 2. Now displacement is also kind of length, so I got ml square t minus 2, okay? Right, power, work done upon time, right? Yeah, so ml square t minus 2, work I already got, right? ml square t, now again one time, so I'll get ml square t minus 3, isn't it? Kinetic energy, see, numbers are scalars, I'll not count them, isn't it? Yeah, so how much it is? M, velocity L square, t, again minus 2, okay? Every energy will have same dimension, so this will also, without knowing anything, I will write ml square t minus 2, okay? Any kind of energy will have same dimension, right? So you have to remember each and every formula which we have written here, right? Now these are from class 9th and 10th, so they are very easy for you, okay? Right, now find me the dimension of G, right? The next question is that find dimension of G, which is a gravitation constant, right? Okay, can you find it? I will not tell you the formula. Very good. Okay, so force is equal to G m1 m2 upon r square, right? Yes. So G, how much I get? F r square upon m1 m2, because both are masses. This is what I get, G, right? Force, sir told me directly remember the formula mlt minus 2, right? R is a kind of length, L square. M is a kind of mass, m square. Yeah. So G, the dimension of G I got m minus 1 L to the power 3 t minus 2. Yes. Okay. So this is a formula you have to remember. Okay. Similarly, like this, you have Coulomb's law, right? What you have? Coulomb's law, which you'll be studying in. So that tells you the forces between two charges, right? That is equal to K Q1 Q2 upon R square. Just similar to that. Okay. So remember, what is the Coulomb's law? Right. Okay. Coulomb's law tell you the forces between two charges, right? These are the charge, right? Q1, Q2. Okay. And gravitation tell you the forces between two masses, right? These are the mass, right? M1 and M2. Okay. Coulomb's law is K Q1 Q2 upon R square. Gravitation is G M1 M2 upon R square. Okay. This value of K is equal to 1 upon 4 pi epsilon naught. Okay. Remember, what is the value of K? 1 by 4 pi E naught. Epsilon naught. Okay. Great. Awesome. So this is what it is, right? Now you have something called as surface tension. Okay. Right? Surface tension. Right? Now, where you'll be studying the surface tension in fluid mechanics, okay, which is the formula F equal to SL, right? You have water, isn't it? Right? The water is the water particles have forces between them. Do you know that? How do we know that? When you take a water droplet, right, it turns round, isn't it? Hydrogen bonding, right? So there is a bonding between them, and this is the reason why it turns brown, okay? Because they have forces between them, and that forces make them round. Or else you see some insect that are flying on that are there floating on the water, isn't it? So that is also due to the surface tension. So that surface tension is L. This L is length. Okay, this L is length. So S, you get it as F by L, isn't it? Yeah, and this is actually MLT minus 2 divided by L, right? So this is MT minus 2. This is surface tension. Okay, MT minus 2. Coefficient of viscosity. What it is? Coefficient of viscosity, right? What we call it is eta. Eta. Okay. So first of all, tell me what is surface tension formula? Great. Now coefficient of viscosity here, F is equal to 6 pi eta RV. What it is? F is equal to 6 pi eta RV. Okay. Both of these things we'll be studying in fluid mechanics, where we'll be studying fluid mechanics, right? So if I have to find this coefficient of viscosity, I will get it as F upon 6 pi RV, isn't it? This eta I get. Can you find the dimension of this eta? Now, I'll tell you what is viscosity, right? You have water, right? Any liquid you have, okay? So liquid also have layers, right? Isn't it? Liquid have layers. Even if you cannot see it, have layers, right? So these layers have some kind of friction between them, right? These layers have some kind of friction between them, right? This friction, we call it as viscosity. That's it, right? Suppose you take water and oil, right? Right? So suppose if you take water and oil, right? So water you will find if you rotate your hand in water, it would be difficult for you, right? Put your hand in, and oil is very smooth, isn't it? Why? Because there is no friction between the layer. Oil is, that's why, very smooth. There is no friction, but water have friction between them. Okay? Right. So find me the dimension of viscosity. Okay. M, L minus 1, T minus 1, right? Right? Good. Now the thing I do here is torque. You know this, right? Can you tell me what is torque? Yeah. Right, like you do take a door, isn't it, right? Door is hinged. If you try to move it from here, okay, it will require a lot of effort, isn't it? But if you try to move it from here, easily you can open the door, right? That's why your handles are there in the end of the door, right? Not where the hinge is, okay? So any hinge is there, right? From that you calculate the perpendicular distance and you apply a force, right? So force will also become larger, right? It will get larger and larger. So torque is force times perpendicular distance, R, right? Right? F times R. This R is actually perpendicular distance. Did this started rotation for you? No, I think so. Yeah, so yeah. Okay, so how much this is? 4 times perpendicular distance, right? So what is this? Can you find me the dimension? Force, we have mlt minus 2. R, I have L. So ml square T minus 2, isn't it? This is the same dimension as energy, isn't it? So what we get to know from here that, see, they can have the same dimension, but they are not the same physical quantity, okay? Note, you have to write that two different quantities, right, can have same dimensions, right? Can have same dimensions, but they can be entirely different quantities, right? Entirely, yeah. We can express torque in joules. We can express torque in joules, no, right? Torque you will always express in Newton meter, right? Force into R, torque will be Newton meter, right? But we can find a relationship, right? We can find a relationship, right? Right. Okay, now the next thing I'm telling about, this is about the rotation only. It is moment of inertia, right? Moment of inertia. What it is? mr square. Okay. What are its dimension? ml square, right? Do you know what is moment of inertia? Okay, right. You know what is inertia? Newton's first law, inertia, right? What it is? Yeah, right. See, what is actually means that, suppose a body have a greater mass, isn't it, right? So you will require a lot of effort to move, isn't it? Right? If a body has smaller mass, easily it can be moved, right? Same way, if a body have greater mass and it is moving, so you will require a lot of effort to stop it, right? Yes. Now, moment of inertia is what we do for rotations, right? What happens in rotation, that suppose you have an axis, right? And here there is a mass, isn't it? From here there is a mass, isn't it? Like say r distance, right? So as we studied in torque, right, that as this distance r increases from the hinge point, yeah, your force also multiplies, isn't it? Yeah. So suppose you have a mass here and suppose you have a mass here, isn't it? So both of them will have different amount of forces, isn't it? Same force F I applied. So this will become F times R. Here torque will become F times R, isn't it? But here torque will become F times R, and this R, suppose I take this R1, right? So this R1 is greater than this R, isn't it? So this force will be much more greater, even if they have same mass, right? So moment of inertia is actually that it is a mass in rotation. What it is? Right, mass in rotation. Like mass, how do you consider in rotation, right? Where distance from the axis is also considered, right? Got it? Right, so moment of inertia is actually mass moment of inertia, right? So this is a quantity, mass is a quantity which is resisting your force, isn't it? Yeah, mass is a quantity which was resisting your force. Moment of inertia is a quantity which is resisting your rotation. That's it. Okay. And it is represented by sum of products of length. Got it? Right. So, right. And we'll be studying a lot more concepts by this. Right. Okay. So, yeah. Now you have, say, angle, right? Angle is what? Theta is equal to length upon arc. I already tell you, right? LL will cancel. So L to the power 0 means dimension 1, right? So means M0, L0, T0, right? So angle is a dimensionless quantity. Okay. That's why it is kept in supplementary quantities. Okay. Right. So one more point to learn from here, that whenever power is zero, okay, means dimensionless quantity, right? Okay. Right. Now you have, so these are the things I'm telling you, right? Why? Because you can have the whole hint of what will be going on in physics. Okay. Now you have angular velocity, right? Yes. So which you represented by omega, and here angular velocity, do you know? It is actually angle upon time, right? Angle is how much? 1, right? T, isn't it? So M0, L0, T minus 1, right? Right. Now V is equal to R omega, right? This omega is actually V by R, I'll tell you, right? This was the normal velocity, you also consider radius into it, right? You have the normal mass, also consider radius into it, right? You have the normal force, also consider radius into it, isn't it? So normal velocity, also consider radius into it, okay? So V equal to R omega, right? Read this formula 3 times. V equal to R omega. V equal to R omega. V equal to R. Whatever formula I write, they should be there in your mouth, okay? Now again, you have angular acceleration, right? Angle by time. Right. So how we denote it? We denote this thing by alpha, right? Angular velocity we denote it by omega. Yeah. So angular acceleration is how much? Alpha is equal to delta omega by t, right? Yes. So m0, L0, t to the power minus 2, you just now find, right? And then you have t, isn't it? Yes, sir. Angular velocity we just now find out, right? T to the power minus 1, and then you have t, right? So it's just t to the power minus 2. Okay. Yes. You have angular momentum. Okay. Right? So L is equal to how much? mv r, right? V times r, or m omega we have, right? Change in momentum, right? And we multiply mass by it also. Momentum is m times v. This would be m times omega, right? So m, v is lt minus 1. I have L, right? So m L square t minus 1, right? Then how much you have? Stress, okay? Is equal to force upon area, right? Which is equal to mlt minus 2 upon L square, right? mt minus 2, L minus 1, right? So remember each and every formula, right? Then again, very important formula, one question definitely you get from mains here, which is Young's modulus, right? Okay, have you ever seen this Young's modulus? Okay, right, I'll tell you. Suppose you have a wire, right? Okay, you apply force here, isn't it? What you apply force here, right? So what will happen? This wire will resist, isn't it? Yeah, but if it is a soft kind of wire, this will change, isn't it? Yeah, and this will expand, right? Suppose this expand by delta L. L was its length and delta L its expand, right? So as it expands, it will apply some force over here, right? This force is due to expansion, how it apply, right? And even if you expand more and more and more, it will go through a kind of, right? It will go and it will start breaking it, right? So at some point, this force will be maximum, then it will start breaking, right? This you call it as breaking stress, okay? Right? So this is the force which is applied due to its extension, right? Yeah. So force, suppose its dimension is A, right? So this is expressed by Y delta L by L, right? This Y is Young's modulus, right? So can you find me the dimension of Young's modulus? Good, right? M1 L minus 1 T minus 2. So very important thing you have to remember, okay? You can get the question directly over there, right? Now you have charge, right? So I is equal to Q by T, isn't it? Yeah. IT is equal to Q, right? No need to tell you this thing, right? You have density. No need to tell you this thing, right? Right. Find the dimensional formula, right? Dimensional formula, okay, of this thing. Density, right, times force upon momentum, right? This is the homework question which you have to do, right? Good. Okay. Again, you have spring constant, okay, which you call it as force constant. Yes. F is equal to minus kx, right? Suppose there is a spring, right? And you expand it by k length, right? So this also spring will start applying force backward, right? Yeah. So this is what you call it as spring force, okay? So this k you can find, right? MLT minus 2 divide L, so MT minus 2, okay? So, right, and okay, so you just remember these formulas. I'm not starting with a new thing here, right? And from next class, the unit and dimension will be over, okay? I'll tell you everything regarding that. With the IIT JEE level, it would be over. Have you solved HC Verma of this? Solve it, okay? Yeah? Will you solve it, right? Okay, right? So I'm keeping the class till here, right? And you solve HC Verma of this fully, okay? Within next class, like tomorrow, your unit and dimension will be over. And then we'll be going for your next thing, that is mathematics, right? Pre-mathematics, basic mathematics for your this thing, right? Right. And then we'll be going with vectors, then kinematics. Okay? Okay. So right, Sunny, we'll meet again in the next class. Till then, bye-bye. Take care. Have a nice day.